So for today's, we are going to summarize chapter 4 entitled Network Access. Let's start. Types of connections. Okay. So as we can see here, this is an embed. This is a router. This is an internet connection, and this is the Ethernet switch. And somehow you can put a wireless antenna, and and you can connect your computer to either one, two, three, or four Ethernet ports. A type of physical connection used is dependent upon setup of the network, and you can't even uh, a wireless connection or cable connection. Okay, with wireless devices, data transmitted using radio waves. The use of wireless connectivity is common as individuals and businesses alike discover advantages offering this type. Switch devices and wireless access points are often two separate dedicated services, device that dedicated devices which network implementation. However, also okay, let's proceed to the other. NIC or interface cards connect a device to the network. Ethernet network interface card are used for a wired connection as shown in figure 1. This has a NIC and the Ethernet is connected to network interface card. Now connect connecting to the wireless LAN with a range extender. Okay, that's as a Twitter cover. Okay, and figure 2 shows the wireless range extender can be used to generate wireless signals to other part of the house. For example, my wireless signal is my wireless router is on the what you call this launch of our yung nasa sala ng bahay namin. Then the range hindi siya abot sa loob ng kwarto, so I will going to put a range extender so that the the wireless um the wireless connectivity is will able to uh feel the my room. Uh what I've said is yung wireless connectivity is makakaabot siya room sa room ko pag may if I have a range extender. So next, the physical layer. The OSI physical layer provides the means to transport the bits that make up data link layer frame across the network media. This layer accepts complete frame from the data link uh, layer and encodes it as a series of signals that are transmitted onto the local media. The encoded bits comprise a frame are received by either an end device or an intermediate device. Intermediate device. So here we can see the source node and the destination node. The source node begins with an application, and the application data was was encapsulated with it and becomes a segment on the transport layer, and on the network layer it will become a packet with a header. And the data link will become a frame, and when it comes to the physical, it will the encapsulated data will be turned into a bit, then flow to the media and received by the piece first by the physical layer. It will then encapsulate the bit and become a frame, then encapsulate the frame and become a packet, and then encapsulate the packet and become a frame, and become data for the application layer. The next, the physical layer media. The physical layer will can use either copper cable, fiber optic, or wireless. On the previous video, I discussed that the copper cable, was it used to uh, as a signal, and also the fiber optic, and also the wireless. Next, the physical layer standards, protocols operating from upper OSI layers performed in software designed by software engineers and computer scientists. The services and protocols in the TCP/IP suite are defined by IETF, or Internet Engineering Task Force. The physical layer consists of electronic security, media, and connectors developed by engineers. So here, the physical layer was built by different organizations. Here, that that is in here. So you can pause the video to read this these things. The next, okay, the functions. Functions is physical components. The physical components are the other three function areas. Physical components, hardware device, media, and other connectors that transmit and carry signal to represent bits. Hardware components such as NIC. Physical components is mostly on hardware of networking. Next function is encoding. Encoding is a line of coding is a or line encoding is a method of converting a stream of data bits into a predefined code. So the bit will be turned into a code. Code grouping of bits provide predictable pattern that can be recognized by both the sender and the receiver. In other words, encoding is the method of pattern used to represent digital information. So codes is we can call this codes that represents the digital information of the data. Next is signaling. The signaling represents by ones and zeros, by one and zeros. The method of representing the bits is called signaling method. Okay, then with the frequency modulation, FM amplitude modulation, modulating wave, carrier wave, and FM signals and AM signals is I think FM signal is more slower than amplitude modulation. Okay, bandwidth. Oh, my internet is so slow. Bandwidth is different physical media support the transfer of bits at different rates. This is unit of bandwidth, abbreviation, and equivalence. Bits per second is B per seconds, abbreviation, and 1 B per second is fundamental unit of bandwidth. Okay, the kilobits per second is 1 kb per second equals to 10 raised to 3 bps or 1000 bps. Then megabits per second is 1 raised to 6 bps or 1 million bits per second. And gigabits per second, uh, 1 gbs is equals to 1 billion 1 billion, what to call it, 1 billion bits per second or 10 raised to 9 bps. A terabits raised to 1 TB per second is equals to 10 raised to 12, or and okay, that's how we that's how that is the equivalence of bandwidth, and data transfer usually discussed in terms of bandwidth and throughput. Bandwidth is the capacity of medium to carry data. And this one I should put here. Okay, let's proceed. Wait. A combination factor determines the practical bandwidth of a network. The properties of physical media, uh, the technologies chosen signaling and detecting network signal. These two, this, these are the combination of factors that can determine a bandwidth of a network. The properties of physical media, if we're using a fiber optic or copper wire, and technologies, or what technologies are we using. Physical media properties, current technologies, and law of physics. Law of physics all play a role in determining the available bandwidth. Okay, let's proceed. This is the throughput. Throughput is a measure of transfer of bits across the media over a given period of time. Due to a number of factors, throughput usually does not match the specified bandwidth in physical layer implementation. Many factors influence throughput, including the amount of traffic, the type of traffic, the latency created by a number of network services. So the factor that influence throughput is the amount of traffic, kung gaano ba kadami nasa network natin, and kung ano ba yung network natin, then yung latency na nabubuo gawa nung dami ng network device. Na, the latency refers to the amount of time include delays. So the latency is the delays created by the number of devices connected or encountered between source and destination. And okay, let's proceed. Types of physical media. Okay, physical layer produces representation and groupings of bits, voltages, radio frequency, and live pulses. An example standard of copper media are type of copper cablings, bandwidth of the communication, type of communicators, pin out colors, maximum distance of the media. So on this section, we are able to know the type of copper cabling. These things we will going to know these things. Uh, and here we are able to see we can see that there's a I think it's a router here. Okay, 1941 router, and we can see that it has a 2 gigabit internet interfaces, a USB a Type A connector, management ports, which console ports, and SHDSL interface, and fast Ethernet switch ports to that we were able to connect to our devices. Now let's proceed. Um, the characteristics of copper cabling. Network use copper media because it is inexpensive, easy to install, and has low resistance to electrical current. However, copper media is limited by distance and signaling interference. Copper media is it can be on short distances. It can be used for a short distance, and it's an inexpensive. It's a cheap cable that we can use that to transfer a data to a network, and it is installed. Just plug it on the Ethernet port like that, and but it has low resistance to electrical current because it delivers data through a impulses, electrical impulses. Data is transmitted on copper cables as electrical pulses and detector. Okay. Uh, The timing and voltage values of the electrical pulses are also susceptible to interference from two sources. It is from electromagnetic interference or radio frequency interference. AMI and RFI signals can distort and corrupt data signals being carried by a copper medium. So, the potential source of EMI and RFI include radio waves and electromagnetic device. So, for example, our copper cable is near to a electromagnetic device, it can corrupt the delivering of the data. Crosstalk is disturbance caused by electric or magnetic fields of signals on one wire to the signal in adjacent wire. Okay, crosstalk, parang ma-disrupt din niya yung it will disrupt the delivery of the message, also like on the EMI and RFI. But it is on crosstalk, it is a disturbance caused by electric or magnetic fields of a signal. Then, as we can see here, this is a pure digital signal. This is a interference, and this is digital signal with interference. What the computer and this is what the computer reads. So, may pag-iiba. And supplement of copper. So, okay, let's proceed. Copper media. Copper media there are three main type of copper media: the UTP, STP, and coaxial. A UTP is unshielded twisted pair, and the STP is shielded twisted pair, and the coaxial is the cable used for common television. Okay, let's proceed. The UTP cable. The UTP cable has an outer jacket, a twisted pair, and a color-coded plastic insulation, which it which we use the color plastic insulation to create an Ethernet unshielded twisted pair of Ethernet cable. We'll just put RJ45 on the as the header. So cabling most common. It is the most common cable on the networking media, and in LANs, UTP cable consists of four pair color-coded wires that have been twisted together. So it provided an outer jacket to protect the wires inside, and the twisted pair to protect the signal from interference like EMI and RFI, and color-coded plastic insulation electrically isolates wires from each other and identify each pair. Okay, this the colors for the identification of each wire, and the twisted pair it is twisted to protects from the signal from interference, and the outer jacket will going to protect the copper wire from physical damage. Let's proceed. Shielded twisted pair cable or STP. STP is very different to the UTP because it provides better noise protection than UTP cabling. Uh, but it is more expensive and difficult to install than uh, than UTP. But they are both they can uh, we can use them both as a RJ45 connector. They both it both uses RJ45 connector. Um, the STP has Jarrett, which it can it can protect to be damaged from outer from the it can protect the wires, then braided or foil shield for to counter EMI and RFI, and foil shield for and twisted pairs. So as we can see on the picture, the wires are very secured inside, and to gain to gain the full benefit of its shielding, STP cables are terminated with special shielded STP data connectors. Okay, coaxial cable, coaxial cable or coax for short, gets its name from fact that there are two conductors that share same axis as shown on the figure. This is the B and C, the N type and the F type of the coax cable. It has the outer jacket like the STP and braided copper shielding and plastic insulation inside and a copper conductor. It does not it doesn't use the twisted wire. It is just a single. Then it's coated by the plastic insulation and braided copper shielding and an outer jacket. It, the copper conductor used to transmit electronic signals. Other flexible plastic insulation surround a copper conductor. The insulation material is surrounded by a woven copper braid here, and an entire cable covered with a cable jacket. And I think the different type connector used with a coax, although UTP cable essentially replaced coax cable in modern Ethernet installation. So before they used coax, but now they most of us use UTP cable. Wireless installation coaxial cables attach antennas to wireless device. The coaxial cables carry radio frequency energy. So as you can see that on our old televisions, we use a coaxial cable to connect the antenna to the TV, so the antenna can transmit radio waves and convert it to our televisions. Then cable internet installation, cable service providers provide internet connectivity to their customers by replacing portions of the coaxial cable and supporting amplification elements with a fiber optic cable. However, the wiring inside the customer's premises is still coax cable. Next, copper media safety. Okay. The separation of data and electrical power cabling must comply with safety codes. Cable must be connected correctly, so it should be plugged at the Ethernet port correctly so that it will able uh, to flow to let the data flow on it. Then installation must inspected for damage. So if one cable is damaged, so you should replace it by a new one and uh, fully functional one. Then next, equipment must be grounded correctly. So it should be not it should be properly managed. So fire hazard exists because cable installation sheets may be flammable, produce toxic fumes when heated or burned. So fire hazard exists on this type of cabling. Electrical hazards are potential problem also because as we know, the copper media uses electrical pulses to deliver data. So electrical hazard is potentially a problem because of the copper wire conduct electricity, and the result of undesirable voltages and current can include damage to network devices. So you must that's why the equipment must be grounded correctly to avoid damages to the network devices and connected computers, or injury to a personnel or to a network engineer that working. Okay, let's proceed. Properties of UTP cabling. When used as a networking medium, UTP cabling consists of four pair colored copper wires. Mm, I think the pair one is the orange. This is the pair. Uh, pair. Wait. Uh, let's look at the next sections about the color coding for this. Now, let's proceed on this. Cable does not use shielding to counter effects. Instead, cable designers discovered that they limit the negative effect of crosstalk by Cancellation. Designers now pair wires in a circuit. When two wires in an electrical circuit are placed close together, their magnetic fields are the exact opposite of each other. Therefore, the two magnetic fields cancel each other and also cancel. Okay, that's why the the wires inside cable is twisted because to cancel out the EMI and RFI and both of their magnetic fields. Next is varying the number of twists per wire. So not only the twisted but there needs also to know that how many twists are there in that wire. Okay, then UTP cable relies solely on the cancellation effect produced by twisted pairs to limit signal degradation and effectively provide self-shielding for wire. Okay, let's UTP cabling standards. Okay. Category 3 cable UTP use a voice communication most often used for phone lines. Um, Category 5 and 5E cable UTP use data transmission, supports 100 Mbps and can support 1000 Mbps, but it is not recommended. So CAT 5 esports 1000 MBS or 1 gigabyte. No, not 1 gigabyte. Then category 6 cable uses data transmission and added separators between each pair of wires, allowing it to function a higher speed, 1000 MBS and or Mbps to 10 Gbps. Okay. UTP conforms to the standards established jointly by the TIA or EIA, especially human cabling standards and LAN installation. So some of the elements defined are cable types, cable length, connectors, cable termination, method testing. Okay, cables in high categories are designed and constructed to support a higher data rate. So, pagtaas ng cable, pagtaas din ng data rates niya. Then, okay, then let's proceed to the next. UTP connectors. UTP usually terminated with an RJ45. This RJ45 UTP, and this is a RJ45 socket. And trying to figure out socket. Then a bad connector is when the wires are exposed and twist, and not entirely covered by the shit, not shit, but shit. Uh, the good connector is wires twisted to the extent necessarily to attach the connector. This is a wrong one. This is a bad one. Don't forget. Improper cable termination can impact transmission performance. Okay, it may cause some different problems if the connector is a bad connector, because it's first of all it's not untwist. It is not twisted, and the it's not fully covered by its coat. So next, types of UTP cable. Types of UTP cable is the type of different UTP cable is Ethernet straight through, Ethernet crossover, and rollover. This this figure represents the T568A and T568B. The blue is the pair 1, the orange the pair 2, and the pair 3 is the green, and the brown is the pair 4. Uh, don't forget this, on pairing this, the stripe colored must go on first, like this. It's the first and the second, the pair 2, and third, and fifth, and seventh. Uh, to let you know that it is a T568A the first color on the RJ45 must be pair 3, which is green, and the separated the separated wire is orange, and the middle wires is color blue, and the last is color brown. But in T568B, the first color should be the pair 2, which is orange, not the pair 3, which is green. And the color is green is a so green is a pair 3 what we call it, pair 3 color. And next is the pair 1, always at the middle, and always at the last, the pair 4. Internet straight through, the standard must be the both ends are T568A both ends, or T568B both ends. It connects the different devices, or host to a network device, such as switch or hub, and the Ethernet crossover. One end is T568A, and the other end is T568B, and it connects the same devices, such as intermediary devices or host devices. And the rollover is a Cisco proprietary connects workstation serial port to a router console port using an adapter. Next, testing UTP cables. To test UTP cables, so following parameters is wire map, cable length, signal loss due to attenuation, and crosstalk. It's recommended to check thoroughly that all UTP installation requirements have been met. Okay, cable pin out. Okay, that's an activity. I've already done that. If you watch my previous video, I already did that. Properties of fiber optic cabling. Fiber optic cable transmit data over longer distances and higher bandwidth. Unlike copper wires, that it doesn't transmit electrical pulses, but it transmit data pulses, and it is completely immune to the EMI and RFI. It's very flexible but extremely thin. And okay, fiber optic cabling is now being used in four types of industry: enterprise industry, FTTH or fiber to the home, long haul networks, and submarine cable networks. Because all of this runs a fast transmission of data. Next is fiber media cable design. Design is it has a jacket, a strengthening material, surround the vapor, prevents fiber cable from being stretched when it is being pulled, and the vapor is here, here the layer this layer, and the vapor helps shield the core cladding from damage. So and cladding made from slightly different chemicals. Then those use a creative core tends to act like a mirror reflecting, and the core is the core actual light transmission element. Okay, that's how fiber media cable design. The next is types of fiber media. This is two single and multimode. The laser light impulses representing transmitted data as bits. So single mode is glass core is 9 microns. Glass cladding is 125 microns in diameter, and polymeric coating. It has a polymeric coating for its shield. It has a small core, less dispersion, suited for long distance. This type of um, this type of fiber media designed for long distance of for example, you have a very long fiber media. It can also travel a fast transmission. Then it uses laser as the light source. That's a single light source, then commonly used at campus backbones for distance of several thousand meters. Okay, up to several thousand meters, it, its range distance. The multimode glass core compare this is 50 or 62.5 microns. It's much bigger than the glass core of single mode. Then glass cladding, also the same, and the coating is shield, simple coating. Then a larger core than single mode, what I said earlier, allow greater dispersion, therefore loss of signal. Okay, it's a best what do you call best effort, I think. Then suited for a long distance application but shorter than single mode. Uses less light source, commonly used with lands or distances of a couple hundred meters. Next, fiber optic connectors. Okay, this is the different connectors: the ST connectors, SC connectors, LC connectors, and duplex multimode LC connectors. Straight tips, ST straight tips on connector use, and the SC connectors, fiber connectors. Sometimes referred to square connectors. Then Wilson connector, smaller version of fiber optic SC. Then the duplex mode, similar to LC connector but using duplex connector. Then this what it's look like. Then okay, testing fiber cables, misalignment and gap and unfinished. Fiber optic media are not precisely aligned to one another when joined. The media does not completely touch the splice connection, and okay, the end finish, the media ends not well polished. Let's proceed. Fiber versus copper. Um, uh, Fiber optic cabling is much better than the UTP cabling. As we can see here, the UTP cabling is has a very low bandwidth supported, 10 Mbps per 10 Gbps, while this 10 Mbps to 100 Gbps. And distance is UTP has is a very short has a very short distance. 1 to 100 meters is enough, but fiber optic is 1 to 100,000 meters. And optic is immune to completely immune to EMI and RFI than UTP cabling. Electrical hazard, completely immune. But the media connector cost is very high. The UTP cabling is low and low. Based on the based on the um, performance, the fiber optic cabling is the best, and based on cost, installation, and safety precaution, I think it's UTP cabling. Properties of wireless media. Wireless media carry electromagnetic signals that represent binary digits to data communications. Wireless media provides greatest mobility of all the media. Why? Because it doesn't need any cable to connect wirelessly. Because as the term wirelessly, there are no wires needed to connect to a network. So coverage area. Wireless does have some areas concerned, including coverage area, wireless data communication technologies, as well as open environments. However, certain construction material used in building structure and local terrain will limit the effective coverage. For example, um, your your antenna was covered by a very big, very tall tree. So that tall tree will limit the what we call the data transmitted to your antenna. Then interference, wireless susceptible to interference and can be disrupted. Such common devices as household cordless phones, some types of fluorescent lights, and microwave ovens, like that. Security, wireless communication coverage requires no access to a physical strand of media. Therefore, devices and users not authorized for access to the network can gain access to the transmission. Shared medium, WLANs operate in half duplex, which means only one device can send or receive at a time. And types of wireless media: Wi-Fi, Bluetooth, and Wi- WiMAX. Okay, WiMAX. On Wi-Fi standard, IEEE 802.11, wireless LAN, WLAN technology commonly referred to as Wi-Fi. Okay. And the next one is Bluetooth for file sharing, WPAN, wireless personal area network. This is used for sharing device and this to connection for the internet. The WiMAX is commonly known as worldwide interoperability for microwave access. This point-to-point multi-point topology to provide wireless broadband access. Then each of these standards physical layer specification applied areas that include data to radio signal encoding, frequency and power transmission, signal reception and encoding requirements, antenna design and construction. Wireless LAN. A common wireless LAN data implementation is enabling device to connect wirelessly via a LAN, a wireless access point, AP, concentrates the wireless signal from users and connect existing copper-based network infrastructure such as Ethernet. Home small business wireless routers integrate the function of a router switch and access point into one device shown in the figure. Wireless NIC adapters provide wireless communication capability to each host. Let's see. Data link layer. Okay, data link layer prepares network data for physical network. It means it it encapsulated all of the data that was encapsulated on the different layers and preparing it to convert into binary and go through a media. Then the data link address, it needs the destination MAC address and source MAC address and also the so layer it needs the layer 2 header. It will add a layer 2 header to an layer 3 IP packet. Then, then next, data link sublayers, the logical link control or LLC. This upper sublayer communicates with the network layer. It places information in the frame that identifies which layer protocol is being used for frame. The information allows multiple layer 3 protocols such as IPv4 and IPv6 to utilize the same network interface media. So the media access control or MAC, this lower sublayer defines the media access um, process performed by the hardware. Okay, the MAC address is more on the hardware part of a network layers. Then the logical link control or LLC is on the upper layer, or it is on the data link. Then media access control or MAC. They are both in data link, but it's more associated with IPs. IP address dial. line, go to the dish, and go to the wireless router. Data link layer protocols govern how format frames using different media. Each hop along the path is interpreted devices accept frames from one medium that encapsulates the frame forwards. Okay, next, providing access to media. Transfer of frames. Okay, and and this figure, the data was transferred of frames. The the first transfer is it is an inside the LAN of a router. Then after our router, if it needs to travel a serial connection, it will be changed to a one the LAN header and the LAN trailer will be changed as one header and a one trailer to travel across the serial connection. A sharp along path or router interface encapsulate the packet into the appropriate frame. And the suitable media access across method is used to access each link in any given exchange of a network layer. So that's the it depends on the type of a media to before the encapsulated message change its header or trailer like what have happened here the LAN header after it flowed to the router that is connected to a serial connection with another router, it changed to a one header for it to be sent to using a serial connection. Then, at each hop along the path, a router accepts frame from a medium. The router accept frame from a medium and they encapsulate the frame. They encapsulate the frame into a new frame with a one header and one trailer and forward the frame to an appropriate medium. That's how it works. Controlling the access. Okay, physical and logical topologies. The physical topology refers to the where does the devices where does the devices are. For example, this is in rack one, shelf one, and rack one, shelf two. It all under room 2124. And the other is like how it like how this created on where are they, where term are they, and on what rack are they, on what shelf are they, like that. Then the logical topology. The logical topology is more on the logical representation with a specific ports and network IP address on what IP is it connected on, yeah, and what type of media used to connect um to that device. Then common physical one topologies is point to point. The first one is point to point, simplest, consists of permanent link between two endpoints. And the next is a hub and spoke with a one at the middle that they are connected. Then all of the other devices are connected to the middle, to a central site. And the next is a mesh. Mesh is provides high availability but requires that very end system be interconnected for every other system. So it means that every devices are connected to each other with a point-to-point link. Next, physical point-to-point. Like a node is created by a serial connection to the network and the network connection to the node 2. It's a point to point because as we can see, there are only two routers uh, in this figure that are connected to each other. Next is logical point to point topology. Hmm. Okay, logical point to point topology is there are source node and a destination node. But in the middle, uh, there are different different intermediary devices that the source node will going to that the frame will going to pass by to reach the destination node. Okay. Then physical LAN topologies. It can be star topology, extended star topology, bus uh, bus topology, and ring topology. Star topology is and devices that are connected to central intermediate device, and the extended star is it's like a star topology, but the central intermediate device is connected to another central intermediate device can that can be that will able to connect all of these devices to one another. And the bus is changed to it bus all end system are chained to each other and terminated in some form on each end. Infrastructure devices such as switch are not interconnected, okay, and ring and devices are connected to their respective neighbor. Half and full duplex. Half duplex is alternate process of sending and receiving a message, and the full duplex is they are both sending and receiving one at a time. Uh, they are both sending and receiving every time that there's a message. Next, media access control. The frame. The frame always have a header and data and trailer. In a fragile environment, power controls are needed to ensure delivery that header and trailer fields are larger as more control information is needed. Fragile environment. Next. Frame fields. Frame fields always have a header, packet data, and trailer because frame encapsulates a packet data to become a frame. So the header composed of frame start. It flags that it is the beginning, and addressing indicates the source and the destination, and the type um, identifies the layer 3 protocol in the data field, and the control is the QoS or mostly flow control. Then the data contains a packet, the packet or the data packet, and an error detection, which use for error detection and are included to data from the trailer. And the frame stop that serves as it is the um, last part of the trailer. The next layer 2 address is the data link. Data link always have a destination MAC address and source MAC address as a layer 2 header and a layer 3 with a layer 3 IP packet source IP and the destination IP. Mm, yeah. LAN and WAN frames. Okay. Okay, I think it is also depends on the media that it's going through. This example of layer 2 protocols. Um, okay, let's proceed on. Okay, that's all for the chapter for network access. It's all about the data link and physical layer, and thank you for watching this video. I hope you understand something, and I hope you learn something from me. And thank you for watching.